And welcome again. Okay, and this is a follow-up video to one that includes the, and again this doesn't count towards the pizza party, the FOIL method. And what we did in that particular video is I showed you that there were different ways to multiply these things. And it's just a distributive property, it just looks different. And so one of the things that we did is we multiplied these two. We said that if we have x plus 3 and x minus 5, then we received x squared minus 2x minus 15 as a result. And so now what we're going to do is we're going to work backwards. Typically when we're in grade school and we're taught how to work with numbers, we first learn to add, and then we learn to subtract, the backwards. Then we're taught to multiply, then we're taught to divide, the backwards. The reason being is that we tend to use addition and multiplication to help us with subtraction and division. So I developed this in multiplication format first. Now we're going to go back and we're going to see if we can use that same grid idea to divide. Let's start off. I'm going to go ahead and create a grid, and these grids I always make one term longer than my dividend, the thing I'm trying to divide. And so if I create this box here, I'm just going to go ahead and make, now this is 3 terms long, and therefore I'm going to make 4 terms. 1, 2, 3, 4. Doesn't have to be perfect, just got to get down there. Then I'm going to start by placing my divisor off to the side, but over on this left-hand side. And this is that initial setup. So remember when we were in the grid format for multiplying, we took a row and a column and we multiplied those two things together and put them in the box where they intersect. All right, just as in division of regular numbers, we're going to ask ourselves, okay, well, what do we have to divide? That piece starts in this upper left-hand corner, and we want to divide the x squared. So we ask ourselves, just like in long division, x times what is x squared, and we put that on top. It looks very similar to long division, doesn't it? And so x times x is x squared. So we're going to go ahead and we're going to place that x right there on top. Now, just as in before, we used to say, okay, well now you have to multiply x times x is x squared, you put that underneath. Then x times negative 5 is negative 5x, you put that underneath, and then you subtract them. Okay, well we're going to do it slightly differently, but we still have to go through that multiplication process. X times x is in fact x squared, which is good. X times negative 5 is negative 5x. Going back to the grid when we multiplied, when we were multiplying and we got all done, we added up the diagonals, and that's what that term was. We're going to work ourselves backwards now. We say, okay, well, I know that this diagonal has to add up to negative 2x. So the question is, what do I have to put here to make that happen? So I'm really asking myself the question of what minus 5x is equal to negative 2x. And they're like terms, that's how they combine. And so we find out that in fact we need a 3x. So that's what we're going to put in place of this question mark here. So we put our 3x in there. And then we go through the exact same process. X times what is 3x, and that becomes a 3. And then we say 3 times x is 3x, yes. 3 times negative 5 is negative 15. Now we repeat the question. What minus 15 is equal to negative 15, because that is our last term. And we notice that, well, it's actually right there. We already have what we need. And if you want to add or subtract and not change the value, you add or subtract 0. And so this now becomes a 0. Once you have completed your grid and you have gotten below the terms, below the term of the divisor, so you notice this 3 up top doesn't have an x associated with it. We are now below the term of the divisor, which does. Whatever's left is your remainder. So this is telling you it's a remainder of 0. It divides. And so x minus 5 divides x squared minus 2x minus 15. And your answer is x plus 3. That positive sign, by the way, was there because it was really positive 3 times x is plus 3x. That's why. And so you can use this particular method on any level of polynomials. It works. The only thing that you may want to consider doing, and I highly recommend this to my students no matter what, is if you are dealing with a polynomial that is missing a term, put that term in with a 0 coefficient. If you do not, you stand an extremely good chance of skipping over it in your process. And that's not good, because just like in real numbers, a 0 in the middle digit, doesn't necessarily mean you're going to get a 0 in that middle digit again. It could be something else. So keep that in mind. I'll have another video of a slightly more complicated problem in my next segment.